Hey there, we're back. My name is Seth. I'm here with Evelina. Why don't you introduce yourself, Evelina, and tell us what you do?
Hello, Seth. Well, I'm a mathematician or machine learning researcher working in cancer research, actually, at the Cambridge University. That's what I do during the day, and during the night, I do various sorts of fun data science projects, and I will be talking about one of them today.
Fantastic. So, for those that don't know, I interviewed her in London. The video is going to come out soon. Fantastic stuff. We're like spirit animals together because I love the stuff she works on. I'm a machine learning kind of guy as well, and so I'm pretty excited. So, why don't you introduce what you're talking about a little bit?
Well, I'll be talking about Star Wars.
Yes.
We are all geeks, we all love Star Wars. So I'll be talking about how we can analyze Star Wars and actually how I analyze the Star Wars social networks and how I found out like who is the most important person in the Star Wars universe actually.
My
So
goodness.
stay tuned in if you are interested in that.
And you did this all in F sharp, right?
Yes.
Okay. All right. Well, let's see what you got. You got something to show us on your screen?
Yeah, I'll start sharing my screen and change into my slides. Can you see them
We
now?
got them. Yes, looks
Yeah.
good. By the way,
Nice.
spoiler warning, spoiler alert.
Yeah, if you
Okay.
don't want to have any spoilers, well, just don't watch Star Wars first and then watch the recording of this show.
Yeah. Take a little break and then come back right after this.
Yeah. Well, I will just start my slides because I have a little video here.
Nice.
Just imagine the sound in the background.
I could sing it, but that would be awkward, wouldn't it?
This is just a little intro to get you in the mood.
I should read it like in like a really dramatic voice.
Yeah, maybe you should.
But there are also characters who are important in the film. That's kind of scary talk, though. I'm a little. I don't want to scare people either.
Um,
How did you write this? Is this some? There's like a Star Warsify thing that I've seen, right? Is that what you wrote it in?
yeah, something like that. It's a lot of
Nice.
fun. All right, so let's get started properly.
Hey, look, it's Microsoft. Just kidding.
Hey. Oh no. No. So I'll be talking about the Star Wars social network. And this whole project started as a part of the F Sharp Advent Calendar, which is an amazing project within the F Sharp community. And it was actually started in Japan, and I believe there'll be an interview later on. And the Advent Calendar works in a way that you sign up for a specific date during the Advent before Christmas, and you have to publish a blog post on that specific date. And my day was, I think, about 2 days before the premiere of the new Star Wars.
Nice. So you were thinking about it, right?
Yeah. So I was thinking, well, should I do something Christmassy or Star Wars? Well, it was Star Wars.
Of course.
So I decided to extract the Star Wars social network because I work normally with quite a lot of network data, so this is close to my work. And it's actually quite simple to extract social networks from things like movies because you can look at people who talk together within one scene and then create a link between them.
Hmm.
And that sort of creates the social network. So, what's really nice about movies is that you can usually download a script or screenplay for the movie.
Hmm.
So, I looked at online like, repositories, and turns out it's all online. You can download everything. And another nice thing about scripts is that they have very fixed structure. Every scene starts with like, either int or ext, meaning interior or exterior, where the scene is happening. Then there is some description about what's happening in the scene. And then there are like, names of characters in bold in the middle of the page with what they are saying. So it's very straightforward to extract which characters are speaking in scene together. So I actually downloaded all the script files from the Internet Movie Script database. I am SDB, and they surprisingly have even a script file for the new Star Wars movie, which I'm not sure how legal that is, but it works. And if I look at the HTML code in script, it really follows the standard format of script that you can find on Wikipedia. So you have some pre-formatted text where all the scene beginnings are in bold and all the names are in bold. So that's fairly straightforward, right? We can just extract all the data from the HTML, completely semantic web thing. And what I decided to use was the F# data library, which I think Don mentioned a little. And that's a library in F# that you want to use if you do anything with data. And it has various sorts of libraries or pieces that you can use to parse any sort of data sources. And it has a very nice HTML parser. So I decided to use that. And this is just a piece of code to take an URL of the script of the movie. And then I just loaded the URL and took all the descendants of the pre-tag, which is the pre-formatted text. And then I also just took all the bold elements, which should give me all the beginnings of scenes and all the names.
Mm-hmm.
So this is in a few lines how to actually extract and parse everything from the HTML document.
So quick question, the function seq.head is just pulling the first pre out, is that right?
Yeah, because the descendants function basically just takes all descendants of the pre-tag, and if there are more of them, then it returns a sequence. So in general, it returns a sequence of values, and I'm just taking the first one.
Perfect.
Yeah. So when I first did this, the code wasn't very nice, and it had a lot of regular expressions. And I don't know if it's just me, but I don't find regular expressions very readable.
No, I mean, remember Perl? The whole language was a regular expression. I never had a palette for it either.
Yeah. So when I was actually preparing this talk and I looked at my code again, it was all sorts of regular expressions for finding out if something is a scene or if it's a name and things like that. And I really didn't like that very much. So I looked again at how it actually looks, and I decided, well, if we look at the script, there are only certain elements that I want to extract, and it would be really nice if I can just say, well, if the element is a title of a scene, then do something. If it's a name, then do something else. And what I did was actually write some pattern matching. So if I look at the script, for example, here, all the elements are basically just the titles and character names. And what would be nice is just to take all the elements in the script, here it's items, and run some pattern matching on them. Just match item with either a scene title, then do something, or a name, then do something else, or a word.
And these are all the bold tags that are being passed in the inner text.
It's items.
Got it.
Yeah. And actually what we can do is use something called active patterns in F#, which allow us to write something like a function which you can use inside pattern matching. So this is actually a completely valid code that takes the item, passes it into the active pattern, which is this, and returns, if it's a scene title, then it returns the title of the scene. If it's a name, then it returns the name. And the inside of the active pattern has all the ugly bits. That means all the ugly regex pattern matching. So this is one regex for matching scene names. Then there is one for matching names. You can see that it's quite difficult because names in Star Wars are a mess. You can have dashes, slashes, anything, numbers.
Wow.
And if the pattern matches a scene, then it returns the scene title. If it matches a name, then it returns the name. And otherwise, it just returns the word. So this makes it very nice way to actually extract all the complicated things and hide it within the active pattern. So I find them really usable because then if you are just looking at the pattern matching, you can understand what it's doing and you don't see all the ugly regex matching, things like that. So active patterns are a great feature in F#. Well, this all looks very nice. Well, it's never this easy. When I looked at the code, actually, I tried to run it on all the screenplays of all the 7 movies. And turns out some of them have different format. Some of them don't have the standard format that you are supposed to have in a script. So some of them actually had the character names just in capitals followed by colon. So, for example, like here, this is a script from the first episode, and you can see that it's just the names are in capitals, and there are other things in capitals as well. So it's much harder to actually parse this, and I had to write some more pattern matching, some more regex matching, and it got a bit uglier, but not that much. I basically had to write 2 different parsers for 2 different types of scripts. Well, this all still looks very nice. So I looked at the characters that it actually extracted from all the movies. And turns out, for example, R2-D2 wasn't there at all. Now here he is beeping provocatively. And the problem is that if you look at the scripts, actually, the only thing that's there is, for example, R2 frantically beeps something. So he is not speaking explicitly at all. And he wasn't the only person who was behaving like that. Because, for example, Chewbacca wasn't speaking in the script at all either. So the only way how Chewbacca speaks in the script is like Chewbacca barks a command. And Han shakes his head in agreement. And then Han says, "Boy, you said it, Chewie." Well, you didn't. I really like. I think Peter Mayhew, the actor who played Chewbacca, made a really good job because he was able to put so much emotion and so much expressive power into what he was doing, even though the scripts looked like this. So I can't just throw these characters out of the analysis. So I decided to add them somehow into there. So this is just some like very fancy looking mathematics. The point is that I just looked at the number of times each character is mentioned in a script versus the number of times the character actually speaks with someone. And turns out this is fairly consistent for all the characters, where each character appears roughly 2 times as much as the character speaks explicitly. So I computed this weight, and I could use this weight to basically just reweight the number of times, let's say R2-D2 is mentioned in the script by the number of times he should probably speak in the script.
This is like some crazy TF-IDF score for characters.
Yeah, basically, something like that. So I basically just calculated how many times would R2-D2 or Chewbacca speak in the script if they actually spoke. And this gave me like a pseudo values for links between characters. And I used this to add R2-D2, Chewbacca, and also BB-8 from The Force Awakens. I skipped some of the characters.
Oh no! He's the nicest one.
When you do this sort of analysis, you realize how many characters actually don't speak at all. They just make sounds. So I think I could probably watch all the films and then just note which character appears but doesn't really speak. And I decided, well, maybe someone else can do that. It's all online on my GitHub, so maybe you can have a look and add it if you want to. And also some characters completely messed up my analysis, because in The Force Awakens, and now if you don't want spoilers, then don't listen for a moment, Luke, basically, he's mentioned quite a lot of times in the script, but he doesn't speak at all. He doesn't say a single word. So when I first ran my analysis, Luke appeared like speaking to Chewbacca, speaking to R2-D2, speaking to a lot of other characters. but that was just because he was mentioned a lot in scenes, but he wasn't speaking at all. So I had to add some few other hacks to basically
A
make it spread.
regularizer for Luke speak.
Yeah. So in the end, I decided to add for each character that's not speaking in the script, to add like a list of other characters that appear in similar scenes. And for Luke, this was empty, so he's not speaking now. So this gave me like a list of characters and how they speak together in scenes. And some of the characters, like, it didn't work very well actually, because, for example, this is another screenshot of the script, and if you look closely, it starts with capital T, but the second letter, it's not I, it's actually lowercase l. So it messed up my letter matching and rejects completely. And the script was riddled, full of these like, inconsistencies.
Dang users, man. They always put the wrong stuff in our stuff.
Yeah.
Every time.
Well, in case you are wondering who's Tion Medon, it's this scary guy. But I don't know if they processed the scripts using some just OCR, but yeah, I had to add him manually as well. So in the end, I ended up thinking, well, I have all these like characters that I'm not even sure if they are in the script or not. So I was looking for some list of Star Wars characters to validate my analysis with. And I came across a very nice website called Swappy, which is the Star Wars API. And if you are looking for some data on Star Wars, you can get data on planets, spaceship, vehicles, people, species, everything from this. And it's a lot of fun to play with this. And I decided, well, it's an API, I can probably use it. And I looked at the website, and they listed some helper libraries. And it had Python, Java, Go, Ruby, C#, R, a lot of different languages, but no F#.
Uh-oh.
Then I was thinking, maybe I can use some other language. Maybe I can. But then I decided, well, no, I'm doing this in F#. I will do this in F#. I won't get turned into the dark side. So this is just an example of one of the wrapper libraries for Swappy. And you can see that it has a lot of different just methods with get and set methods. And it's basically just instantiating objects with get and set methods. So it's not like, very interesting code. Well, let's look at how it looks in F# actually. And now I changed into Xamarin Studio. Don was talking about the cross-platform support with F#, so this is running on Mac in Xamarin Studio. And I'll just load the F# data library here. And the Swappy website, actually, it's really nice. It has quite a good documentation even. I'll just go there. And it has information on everything, how to get the data, what resources it has, and it has these example requests. So I can just copy over the URL of the example request and go back into F# and then create something called the JSON type provider. And I'll be looking at data on people, so I'm just creating a type called person with a JSON provider, and I will give it the URL. And what it does, the type provider actually looks at the response from this URL and infers types of all the elements in there. Can you see it?
Yep. Yeah, it looks really good over here.
Yeah. So now I can use this type provider. I can create a function, well, named getPerson, and all these requests work with IDs. So I will just take an ID. And what I will do is I will just use the type provider to load the URL, actually. And I'll just replace the sample ID with the ID that I will give it. And this is actually doing exactly the same thing that all the code that I was showing before in one of the libraries does. So let's see how it actually works in practice. So now if I type let p equals get person, let's take the first person and download it. Oh yeah, I need to change this into a string. Now it should work. Yeah, that's the advantage that, plus, that F# is strongly typed, so it tells me whenever something is wrong. Okay, so now I got information on the person P, so let's see who that person is. So I just typed p dot, and I got information on all the elements in the JSON response that I got from the API. So I can look at the name, and the name is Luke Skywalker. I got it here in F# Interactive. And I can also just hover my mouse over it and see that it's a string. And if I look at some other information, for example, height, I can see that it's an integer. So in case you wondered what's the height of Luke Skywalker, it's 172 centimeters. So I actually went on and did like a full wrapper in F#. It's called swappy F#, and this is the code. And you can see that most of it is just basically just specifying the URLs and creating the types and writing the wrapper functions. So this is the function for a person that I just wrote in my example. So this is the full wrapper for the whole F# wrapper for the whole Star Wars API. And you can have a look at that. It's all on GitHub, and it allows you to do all sorts of crazy stuff. For example, if you ever wondered if Luke Skywalker is the average height or if it's below the average height for a Star Wars character, then we can find that out, actually. I just reloaded my F# Interactive, and I have some example code here. And I will download information on all people that are in the database. This might take a while because it's... oh, it's finished. There is a good internet connection here. So let's see. We have information on 87 characters in Star Wars. And yeah, as I mentioned before, you can look at the height of Luke Skywalker, which is 172 centimeters. And we can also calculate the average height of all characters just by looking at their height in numbers. So let's see. And the average height is 174 centimeters. So Luke Skywalker is actually below average. And I have an example here doing similar thing with eye color. So it's looking at all the characters and just extracting their eye color. And we can look at the response here. And you can see that the most common eye color is actually brown. For example, Han Solo has brown eyes. Yoda has brown eyes, which I didn't know. The second most common color is blue. And the third most common color is yellow, actually.
Wow.
These are some information from Star Wars that you definitely needed to know. So you can go on and play with it, actually. Just go back to my slides. It's all on GitHub. This is the website. There will be also links at the end of the talk. So play with Star Wars. It's a lot of fun, actually. And when I had all the networks, I decided, well, what shall we do? We can visualize them. And I used D3 for that. It's a JavaScript library. Unfortunately, we don't have any wrapper around it, but it's so complex that it's really hard to make a good wrapper around it. But it has a lot of examples online where you can just go on and change your data and play with it. So now, the complete Star Wars social network. This is it. This is the Star Wars network from all the films put together. And the nice thing with D3 is that you get these nice interactive visualizations where you can drag nodes around and play with them. and it's a lot of fun. And this is actually quite interesting because on the left side, it's the social network for the prequels, and you can see that it's quite like, full of links and quite convoluted. And moving towards right, it's the original trilogy and then The Force Awakens. And you can see that the social network is much clearer and the structure is much nicer. And if I look at them a bit more in detail, this is the first episode of the prequels, and you can see that the network is quite big with a lot of characters. And this is the social network for the original Star Wars New Hope. And there are like only a few characters, it's just the major characters, they have strong links between them. So you can immediately see that the prequels were different in this aspect. And when we look at The Force Awakens, it's a bit bigger than the original Star Wars movies. And it has quite a lot of minor characters. For example, like this is Poe with his little pentagram of resistance pilots. It's a lot of fun to just drag things around and play with them. So this network is actually much larger. And I will talk later a bit about how it's different from the prequels and how it's different from the original series. So when I had the networks ready, I decided to look at like who is actually the most central character in the network, who is the most important Star Wars character. And the first, like the most straightforward measure of importance in a network is a degree. So this is just an example, small social network, and the degree is just the number of connections for each node. So for example, this central green node has 6 connections, which means its degree is 6, and this one has just 3 connections. So this tells you, in terms of the Star Wars social networks, how many characters each person speaks to, actually. So this is just formal, how it looks formally. That's not very important. But just the number of connections is not such an important feature. The more important one in terms of communication in a network is called betweenness. And that's a measure of importance in terms of communication or connections in the network. So, for example, this central character, again, he's very important for these 2 nodes. If they want to communicate with each other, they don't have any direct connections, so they have to go through him. But if you look at these 2 nodes, actually they have 2 possible ways how to get information across. So only like half of the information might go through the green node. And that's basically just the intuition behind betweenness. And formally, betweenness is when we look at all different ways 2 nodes can be connected, like the shortest paths between them, and we calculate how many of them pass through the node we are interested in. And then the betweenness of the node is just the average of these numbers. So sorry for all the equations. How would you actually calculate this? It's quite a difficult thing to calculate if you just want to write it from scratch, because you have to calculate the shortest paths between all pairs of nodes. So in R, there is this very nice library called iGraph, where all you have to do is just give it the network, represented by a list of edges in the network, and call a function called betweenness. Well, turns out in F# we can do it in a very similar way using something called the R provider. So it's something similar to the JSON type provider I was showing before, but the R provider gives me access to all functions in R with all the type information they can give me, which is not much. But all I have to do is just call rprovider.igraph, which opens the iGraph library in R from F#, and then call just r.betweenness. And it gives me all the information within R. So this is easy. So how it actually looks in the Star Wars social network. Well, if you look at just the degree, in the original trilogy, the most important character is Luke, of course. And then there's C-3PO, Leia, Han, and Darth Vader. If you look at the prequels, the most important character based on the number of other people he speaks to is Anakin, then Padme, Obi-Wan, etc. But when we look at betweenness, the picture changes quite a lot. For the original trilogy, it's still the same list of characters, only the order changed a little. But in the prequels, actually the most important person is Obi-Wan, then Padme, Qui-Gon, and the Emperor, and Jar Jar. So there is no Anakin even. So it turns out that the most important person in the prequels is even less important than Jar Jar in terms of communication in the network. So that's another thing within the prequels, that the story wasn't that good. That means that the character who was supposed to be central doesn't actually play any central role within the story itself. Because all the characters, when they want to communicate, they have some other paths, some other ways to communicate than through Anakin. So he is not the person who actually drives the story in the prequels. And if you look at The Force Awakens, the new episode, actually the most connected character is Poe, which makes sense because he talks to a lot of different characters in various different settings. But the most important character in terms of betweenness is actually Kylo Ren. And it makes sense because he is the character that sort of connects some of the traditional characters from the traditional trilogy with the new characters. And you can see that Rey is not featuring there very much, but that's just because she has sort of quite a separate story to the other characters. So she doesn't talk to that many other characters, but she has a slightly higher betweenness than the degree. So now the crucial question: who is the most central across the whole story? Well, before The Force Awakens came out, the most important character was Obi-Wan. But now that The Force Awakens is part of the social network, the most central character is actually C-3PO.
Oh my goodness.
Because he appears in all the different episodes and talks to quite a lot of different people. So I suppose that the robots will continue appearing in all the subsequent episodes again, so they will probably keep their central position. But now I have all the networks, and I can also look at some other measures of centrality in the network, or measures of connectivity in the network. So the first thing I can look at is just the size of the network itself. And this is just an overview of all the episodes and how they differ in the number of characters. And these are just the characters that are actually explicitly named in the script. So if there are characters called like Stormtrooper, then they are not here. So the episode 1 had the most. It had 38 named characters. And the number was going down gradually, and then episode 7 again jumped up. So this is quite an interesting thing. And we can look at a bit more information about the structure of the network. For example, well, in episode 1 there was a lot of debate in the Galactic Senate, so it had a lot of characters. But we can look at something called density of a graph, which is a very simple measure that looks at how many edges are in the graph compared to how many edges there can be possibly. So if there are in the story just a few characters that talk together a lot, then the network will have a high density. If there are many characters who don't interact with each other, then it will have small density. So this is just how to formally calculate this. And if you look at the density of the networks for different episodes, actually the first 2 episodes have the smallest density. And then the density went up for all subsequent episodes. And actually from the prequels, I think episode 3 has the highest rating out of them. So maybe the density correlates a little with the quality of the story. And then I also looked at one other more complicated measure of network structure, which is called the clustering coefficient. And when we look at the network, in a social network, it basically means if I have 2 friends, are they friends with each other as well or not? So for example, in this network, if you look at this guy, he has 3 friends, but they have only 2 connections between themselves, and there's 1 connection missing. But if you look at this guy, he has 3 friends again, but they are completely connected. That means each of them knows each other. And in terms of the story, this means if there is just one character that meets other characters that don't interact with each other between themselves, that means the clustering coefficient is small. But if we have a group of people that talk together a lot, and that where they all have a backstory and they all interact with each other, then the clustering coefficient will be high. So again, this is how to calculate this. I'll just skip over this. And I guess you can probably guess how it turned out. The prequels have the smallest clustering coefficient, which means that the characters actually don't interact with each other very much. And episode 4 has a higher clustering coefficient, and surprisingly, The Force Awakens has higher clustering coefficient as well, which probably contributes to it having better story than the prequels. So this gives us quite a lot of information about the structure of the social network, actually. And again, how to calculate that? In R, I would just call functions from iGraph called graph density and transitivity, which is the clustering coefficient. And in F#, it's basically exactly the same. And this makes it really nice because I don't have to change between languages. And I think this is really the future for data science, where you don't use every language what it's good for, but you can stay within one language that you like the most. For me, it's F#, so I can just call functions from R within F#. And I can call other things as well. It would be nice to have a Python R type provider as well, but right now we have R, and R for data science has almost everything, which makes it really great. And if you noticed in my slides, all the graphs that I was showing, they are actually not static. They are all very interactive. I can look at the actual numbers and titles for everything. And that's because I'm using the Google charts with an F# library called xplot. And how to actually plot the things, it's really simple. You just load the Google Charts library and then take your values. Then I just edit labels, the episode number, calculated the percentage, and then passed it into chart.bar. And that creates the chart that I can embed into a website or into slides or anything. And it's nicely interactive, and it's fairly easy to set up, as you can see. I just give it like a list of labels and numbers, and it creates the chart. So that's my favorite way of charting things right now. And I also played with the social network a little bit with Neo4j. I believe there are some F# wrappers for that as well. So I'll have a link at the end of the slides where you can look at the demo. And you might be thinking, well, Star Wars, it's a lot of fun, but can we actually use it for something a bit more useful? So I also analyzed some social networks in the real world. For example, I analyzed the F# social network on Twitter. And I looked at the most central people in there. And you can use similar algorithms in marketing, for example. If you have a brand on Twitter, then you can look at people following you and target the ones that are most central. So for the F# social network, actually the most central person was Don Syme, which makes sense because he's the author of the original version of F#. And then what's quite nice is that on the 3rd place was Miguel de Icaza from Xamarin. So you can see that the F# community actually cares about cross-platform development quite a lot. And the 4th person is Thomas, who's there in Seattle. So you can see that we have quite a lot of important people here from F# now. And also, well, I don't have much time, so I will probably skip this, but this was another example of a social network analysis in real life where they were looking at communication within a company. And they were looking at who is actually the most important person in the company's social network that they could talk to if they want to spread information. And you can use it in various sorts of different settings. For example, if your company communicates on Slack, you can see who actually replies to whom and construct a social network from that. You can look at emails. You can also look at supply grids to see if their if something fails somewhere, where will be the blackout and where you should reinforce your network. Or for me personally, the area that I work with is biological networks. So for example, this is just a photo from a paper I was reading recently, and I work in cancer research, and they were looking at certain genes that are important in cancer, and turns out that in biological networks, they have higher betweenness. And I said, betweenness, I just applied that for my Star Wars social network. And I think this is a very nice thing to do if you want to get some intuition about how these methods work. Just play with some interpretable data set like the Star Wars social network. Because if you look at just betweenness in some complicated biological network, then you probably can't really assess what it means. But if you have intuition from some nice fun data set, you can just transfer the knowledge into some more complicated settings. And I think I went through quite a lot of things. I showed you how I was parsing script files in a functional way with active patterns. I went through data science and how we can use libraries from different languages within F#, how we can use type providers. I gave you some little introduction into network science. And the main thing, I was talking about having fun with interesting data. And again, this might seem just like a toy example, but if you play with something like this, you basically practice all the skills you can then transfer into something like more serious, into your actual work. I'm not saying that Star Wars is not serious. So if you want to learn more, there's some information how to start with F# on the fsharp.org website. You can look at the iGraph package as well. I have all the links here for the things I was talking about. And I actually wrote 2 blog posts where you can find more information about the analysis. And this is how to contact me. And I'm finished.
Nice. All right. Well, let's get your face on again so you can stop screen sharing. That was awesome. So we are out of time, unfortunately, but let's get your face so everyone can say goodbye to you. There you go. There she is. Thanks so much. That was awesome. We went through a ton of different stuff. Obviously, if you have any questions, feel free to reach out to Evelina. She's very responsive.
And just send me a message on Twitter.
She's awesome. Thanks so much for spending some time with us. Thanks so much for watching. We're going to go to Slate so that we can prepare for the next session. We'll see you right after this.